want to become pro in the flip-flop conversion, so this is a video for you guys. So please watch this video to become familiar with conversion of one flip-flop to another flip-flop. The thing is that you will be having one flip-flop with our hand. They will be asking us to convert from one thing to another. So in order to do that, so what is the prime rule is that to convert any flip-flop into other flip-flop, write the characteristic equation of the desired flip-flop. Means what's the flip-flop that we need to achieve, followed by the excitation table of the available flip-flop. So let's see the condition here, how the SR flip-flop can be converted into JK flip-flop. So okay, so JK flip-flop is our desired flip-flop. So first thing we have to first write the characteristic table for the JK flip-flop. So let me write that first, and then followed by the excitation table of the SR flip-flop. Okay, so let me write the headers. So this is J, this is K, so this is Qn, and this is Qn plus 1. So let us first complete this one. So this one we already know, right? So this one similar to that what we have done previously. So 0 0, so 0 0 1, so 0 1 0, so 0 1 1, so 1 0 0, so 1 0 1, 1 1 0, 1 1 1. Okay, so next, if JK input, both the input are 0, then the output will remain same, so that we know. So here 0 and it will return. So when 0 1 is applied, whatever the input, output will be converted to 0. So in 1 0, output will be converted to 1. Then if it is 1 1, output will be toggle. Okay, so now we have written the characteristic equation of the JK flip-flop. Now we have to convert this with the help of this one. So here we have to write the excitation table of S and R. Okay, so when 0 0 is happening, the excitation table will be S and R bar. So when 1 and 1 is there, then X and 0. Okay, so this we already discussed, right? So this is from here. So if you see, so from here, so this is the excitation table. When 0 0 is happened, 0x. So this is 1. So this is the important thing. So please write this for a reference there, and there also you can draw it. Okay, so let me fill it. So if it is 0 0, then again it will be 0x. Then if it is 1 1, then it is 0 1. So if it is 0 1, then that is will be 1 0. Then it is will be x 0 1 0, and for 1 0 to 1 1. Okay, so this is what the thing. So now we need to get the equation for S and R. So for that we need to draw the K-map. Okay, so simple thing. So after K-map we will be getting the equation. From there we have to convert that into our desired flip-flops. So this is 0 1 0 0 0 1 1 1 1 0, right? So this is J, K and Qn. Okay, so we have to repeat this here. So I am removing this one and I am repeating the same. Okay, so I added here. So let me use a red pen here. So whenever this is for S1, so this is for S. So wherever S is 1 and X1, X, so X at 2 position and 1 at 2 position. So here there is 1 and 1 here. So this how can be take is that the don't care condition, if needed only we can take it. So here that is not needed because that will increase our burden of tension. So S can be written as, so here J and here that is a Qn bar. Okay, so here for K 2 times X and 2 times 1. So here it will be X 1 1 and X. So here also don't care is not need to be included. So here if we take R, so this is for R. So R which is equal to K Qn. Okay, so this is what the equation that we are getting. So now let's see how this can be drawn into a diagram. So we already have a S flip-flop, SR flip-flop. So let's bring that to the table. So this one we already have. So the thing is that, so the input SR and the output Q and Q bar. So this flip-flop we have. So we already gave an input also, that is clock. In order to convert this into JK flip-flop, what we have to do is that the J can be the S input, the D to be added like J Q N bar, and R input need to be K Q N. Okay, so for this, how this can be done is that simple thing. So here we are taking output here. Okay, so here we need to have an AND gate. So we are going to multiply two things, right? So here we are having AND gate. So we are multiplying. So here one input will be J. So here one input will be K. Okay. So rest thing we need to map it from here. So if we take the condition here, so then this will be given here. So here the same, if you take the condition, and this need to be mapped here. Okay. So this is Q bar S. This need to be given to S, and this need to be given to R. Okay. So if this is done, then our output will be as same as what the JK flip-flop. So here the thing is that we have only SR flip-flop, but due to this AND gate and this configuration, we now able to see the JK flip-flop behavior at the output. So this is how you can convert to anything. So like this way, you can convert from one form to another form. Any kind of things they will be possible. So let me do one more example and leaving this behind other things to you guys. So how we can convert D to JK flip-flop. The same thing, we have to write the characteristic equation of the decide flip-flop, and then we have to write the excitation table of the available flip-flop. So this is what the thing. So here we have a JFD flip-flop. We need to convert that into JK. So here is the G. So if you write it 0 0 0, so 0 0 1, 0 1 0, so 0 1 1, 1 0 0, so 1 0 1, 1 1 0, 1 1 1. So the thing here would be 0 1 0 0, then 1 1 1 and 0. Okay. So the excitation table that what we can be coming here is that, so whenever the same input is there, the D will be also same. So whenever there is a change in input, then that will be thing. So similarly, the Qn will be same as D. So 0 0 1 1 1 0. So if we write the characteristic equation K map here, so let me do the K map. So 2 4 6 and 8. Okay, so J K Q N. So this is the equation of D. So wherever D is 1, so 1 1 1 1 here. So 0 1, so 0 0 0 1 1 1 1 0. So here mapping will be done like this. So the D can be written as, so J Q N bar plus K bar Q N. So this is how we can write it. So if we are having a D flip-flop, then how this can be converted is this way. So this is D flip-flop. So here it is D. So here it is Q bar, and clock is given. So this one we need to take. So here we need to multiply Q and Q bar. So here output will be taken. So here let me add an AND gate here. So AND gate K will be given here. So K will be given here, and then here actually this is a K bar. So K bar need to be given here. So toggle input. So here another one AND gate where J is given, and another one is taken from the here below. So let me draw it simply. So here the Q bar is taken, and here the Qn is taken. So here Q is taken. So then we have to add both this input to our gate. So if we give like this one, so with the D flip-flop, we will be able to get the behavior as like the JK. So this is one clock. Okay, so now you guys able to think, right? So how we can convert from one thing to another thing. So the following method is applicable for conversion, not only involving SR flip-flop. So anything we can do it. So to convert any flip-flop to another flip-flop, equate the characteristic equation of both the flip-flop by available flip-flop. So that is what the thing that will be having. So I will be drawing one table next class. So how the conversion for all the things. You guys can even remember that, or you guys can even understand how each thing is coming. So in the next class, I will be writing that table. So there, all the flip-flop conversion that I will be handling there. Okay, so here I am closing this session here. So conversion is also done, everything is done. So next class I will be drawing the table, and then we will be starting with the registers. So we will be almost, we are completed some 40% in the sequential circuit. So once the register is converted, then we will be going to counters. So after the counters, we will be completing the sequential circuit. So then data converters there, then memory elements. So I think some quite 10 to 15, some 15 to 20 lectures will be there to complete this. So like, share and subscribe channel. Stay tuned guys. Thank you.